Subtraction is the arithmetic we use to understand differences. When kids are really small, they're going to be using blocks or marbles or whatever else they can get their hands on to count to do their arithmetic. So let's do 5 minus 1. Super easy. They're going to have 5 blocks. They're going to take away 1, and they're going to have 4 left. 4 is the difference. We call it a difference. Let's look at something a little bit harder. As they get older, we're going to start using bigger numbers, things that we may not have enough blocks to count for. So let's say 55 minus 11. Now, just like addition, traditionally, they're going to split this up into columns and have you do each column separately. 5 minus 1 is 4. We know that. 5 minus 1 is 4. Okay, but this isn't actually 5, and this isn't actually 1. So they're not really understanding this concept that they have 55 of something and they're taking away 11 of it. They're not seeing the real picture of what it is in their head. So it's going to be difficult for them to use this method when they are translating that into a word problem. So let's look at it a different way. I didn't need to erase all of that, but let's write it again. 55 minus 11. All right, go ahead and do the ones. 5 minus 1 is 4. This is not a 5 though. This is 50. Same thing with addition. This 5 represents 50 because it's in the tens column. That's a lot of marbles or a lot of blocks. Okay, now I have in my mind the fact that I have a lot of something, which is great because I'm understanding what these numbers actually represent and that they're not just numerals. This 5 represents a 50 and this 1 represents a 10. 50 take away 10 is 40. So I'm going to write 40. Now I've got these two differences here, and I can just put them together to get my total difference. My total difference is going to be 44, because the difference between 5 and 1 is 4, and the difference between 50 and 10 is 40. Now you can always just teach them the trick if that's what they think is the easiest, as long as they're really understanding that 55 is a big number, and 11 is much bigger than 1. Okay, but let's do something a little more complicated where we have to start actually borrowing from numbers. So let's do something a little bit harder. Let's see, we've got 62, and we're going to take away 27. Let's do this traditionally first. I can't take 7 from 2. So I'm going to come over here and borrow from this 6, cross it out, and make it a 5. I'm going to put a 1 right here. 12 minus 7 is 5, and 5 minus 2 is 3. So my answer is 35. Great, that was super fast. It was easy to get there, but I didn't really understand what was going on. I was just doing steps that somebody taught me. So let's do this a different way and see if we can understand what's actually going on here. This is going to help actually a lot of your learners who have difficulties with math if they can conceptualize it. It makes each problem take a little bit more time, but they'll get faster at it as they go. So let's do 62 minus 27. I can't just take 7 from 2, so this is going to be more complicated, but we're talking about the difference. And I like to use distances here. At this stage in the game, they're old enough to understand a number line, and that represents a distance. We'll start at 27 and go to 62. And sometimes if they're struggling with this too, I'll say, okay, 27 is where we're at now. We're going to go on a trip, and we're going to 62. How much gas do I need to get there? Well, this is kind of difficult to just look at this and know what to do. So 10 is my best friend, because 10, I can do anything with 10. 10 is an easy number to add. It's an easy number to subtract. So let's get from 27 to the next closest 10. We're going to come up to 30. Okay, now from 62, let's go down to the next closest 10. Now we've got numbers that are really easy to work with. 27 to 30, I can see that. That's 3. 60 to 62, I can see that. That's 2. And 30 to 60, well, I can see that too. That's 30. And they can break this up and do skipped counting by tens if they need to practice with that a little bit more. But now we have numbers that are really easy to see. 30 plus 2 plus 3 is 35. It took a lot longer for me to get there than the other way, but I can actually see and understand what's going on. If I had 62 apples and I'm taking away 27 apples, This is how many apples I'm going to have left. Let me draw that out a little bit longer for you so that you can actually see how that works. Here's 62. Here's 27. Here's 0. If I have this entire length, I have 62 apples. I'm taking away 27 of them. This whole section here is going away. What I'm left with is right here, the difference. When I subtract, I'm always left with a difference. And I can think of my difference as a distance and calculate it this way. Let's go ahead and do that one more time with another problem. Let's do 44 minus 17. I won't show you the math trick anymore. I think we all know how to do it that way. But let's look at it at the number line. Here's 44. Here's 17. I need to know what I need to get from 17 to 44 because that's the difference. 17, I go up to my next closest 10 because 10s are easy. They're my best friend. And then from 44, I go down to my next closest 10 because I'm headed to 17. Love my 10s. 20 to 40 is 20. 17 to 20 is 3. And 40 to 44 is 4. 20 plus 3 plus 4 is 27. Now the reason why it's so important to understand the math this way is because when you get to higher, more complex problems, you're not going to be able to do these math tricks in your head. And if for some reason you don't have a calculator and you're not understanding what's going on, it's going to be difficult for you to apply these principles to other things. If you have a word problem, however, or a distance problem, or anything else relating to algebra or calculus, you can understand the math that's behind it. It also helps tremendously in doing mental math. This is going to be able to help encourage them to do the math in their minds as well, because these numbers are easily managed in the mind. And I can tell my younger students that the subtraction sign is to remind them that we're dealing with a difference or a distance, and they can go ahead and draw their number line and use that to solve their problem.